Hello, this is Stefan Mozar. I'm reporting from the International Conference in Consumer Electronics in Seoul, Korea. This is the inaugural conference, and our inaugural keynote speaker, Professor Cremers from the Technical University of Munich, is here with me, and he gave us a very interesting presentation on his work. Professor Cremers, my first question to you is, your background is in mathematics and physics, and now you're working in image processing, so that's sort of a unusual combination.
Yes.
Can you tell us how you actually sort of moved into this area?
Yes, so the reason why I moved into image processing and computer vision is because I loved mathematics, but I wanted to do things that really impact our society, that impact everyday life, and this is certainly something that we see now. The impact we have with the technologies we develop is quite substantial, and this is the one thing that I find quite fascinating in this work.
Yes, it is a fascinating field that you're working on. Particularly from your presentation, I found the autonomous driving applications very interesting. Would you mind to elaborate about what you're doing and how you see the future in that area?
So we developed some of the core technologies to enable driver assistance and self-driving cars. So it's all about getting from cameras and other sensors to an understanding of what happens around the car, what happens in particular in front of the car in the driving corridor. You want to see obstacles, you want to avoid obstacles, you want to save lives, and you want to, on the long run, be able to make predictions about what's going to happen in the next few seconds in front of my car, so that the car can react autonomously and in that way save lives. It's a very challenging problem, but we're making quite some progress there.
Yes, that's indeed a very challenging problem. I noticed in your presentation you talked also about how you combine different technologies to identify problem areas like a totally white background or a blue background. And we've heard famously that the Tesla car crashed into a truck because it was a blue background, something like that, and it couldn't identify that it was an object.
Yes, so it is a challenging problem, and one of the things we noticed in the Tesla incident, that it is a challenge that really involves a substantial possible damage. I believe, though, we are on a very good track, and one of the great things about this technology is the technology will become safer and safer with time. The machines learn, they improve with every new generation, they improve, and with every problem solved, all the cars can profit. If one driver makes a mistake, a human driver, the other drivers don't improve. If one self-driving car makes a mistake and learns from it, all existing self-driving cars will profit from that. And so there will be an overall systematic improvement in the technology to a degree that on the long run, self-driving cars will make driving safer than human drivers.
Yeah, that's very interesting and very well research area. But also during your presentation, you talked about different areas that you'll be working on. One of the areas you elaborated on was neural networks. And you also mentioned that you sort of stepped back for a while from artificial intelligence methods, and now you're rekindling it. Can you tell us a bit about that?
So the neural networks have become quite popular again in recent years in the computer vision area, because they allow to solve certain computer vision problems at a level that is unprecedented in terms of performance. Recognizing objects in images, recognizing objects in videos, segmenting images into semantic components. On all of these challenges, neural networks seem to be outperforming previous techniques and algorithms, so they do hold quite some promise in terms of understanding the world from images.
Yes, that's true. Last question I'd like to ask you is, the medical field is also advancing very fast, and a lot of consumer techniques and vision processing areas finding very useful applications in the medical field. Do you see a big future in that?
Oh yes, definitely. Medical image analysis is one of the biggest areas of image processing and computer vision in terms of the market value, definitely, but also in terms of the importance for society. The ability to diagnose certain illnesses and diseases from imagery data is very important. We're scanning people these days with more and more imaging technologies, two-dimensional, three-dimensional scans over time. We can get 4D ultrasound, volumetric ultrasound over time. There's so much data that we can acquire. One of the core challenges that remains is to interpret that data and make sense of it automatically. To date, we still rely heavily on medical experts that manually look through images to see whether there's a tumor or something else. We're hoping that on the long run, a lot of this manual human labor can be replaced by machines that will then ideally perform better and more robustly, more with less errors than the human observer will.
Yes. So there's very challenging opportunities ahead for us to improve in the area of vision processing. I'd like to thank you for your very interesting keynote that you presented today. And for the viewers of this clip here, I believe the keynote will be available on CESOC YouTube TV. So I recommend highly you come back and have a look at that video clip. Thank you, Professor Cremers.
Thank you so much.